So it's an honor to present you a part of my work on the continuity of the cumulative curves in the network calculus. So that is to say, I will come back on the basics of the network calculus. Then to organize my talk, I will first introduce the subjects, speak about the motivation and the objectives. Then I need to come back just a little bit, don't worry, on the mathematical background, like the set and function that I will use, the definition of the cumulative curves and the convolution. And then we can show you the relation, the equivalence between the left and the right cumulative curves. Finally, I will illustrate the usage of the results with a simple example. Well, let's start with the introduction. So when I started to work with the network calculus, I understood that the question of the continuity on the cumulative curves was very important, and that was a bit difficult for me to understand. Why do we need to choose the left continuous cumulative curve rather than the right ones? So, and I was a bit reassured when I saw that 20 years ago, that was also a difficult question. So after reflection, the left continuous cumulative curves won the fight, and we mostly developed all the theory around the left continuous assumption. So in the following talk, I will speak about left world for all the results and studies developed with the assumption of the left cumulative curves. However, in the last few years, some research are developed with the right continuous cumulative curves. And similarly to the left world, I will talk about right world for all the results developed with the right continuous cumulative curves. And we have then results in the two worlds. And the question is, can I use all the results, those developed with the left assumption and those developed with the right assumption? I found an answer in the book, that is, it would be nice to stick to either left or right continuous functions. However, depending on the model, there is no base choice. So the aim is to see how we can stick to the left or right function. We see two possibilities. So the first one is reprove all the results from the world from one world and to in the other one, and vice versa. So some work was done, for instance, with the property that a strict minimal service implies a min plus minimal service, or the expression of the static priority service and blind multiplexing service. But this is just a non-exhaustive list to see that it's still we have still work to do, because, for instance, as illustrated, all the DRR service and WRR service are developed only in the left world. And the link with CPA theory is only developed with the right in the right world. So that is too hard. So we find another possibility that is to find relations between the left and the right worlds to be able to transfer results from one to another. So we will ask three main questions: what is preserved, what is lost, and what is not too much modified. So that's the aim of the study. Fine, I need to come back just a little bit on the mathematical background. So first, I will introduce some notation, like I will say f for the piecewise continuous function, and logically I will say L for left continuous function and R for right continuous one. And if I take a subset of any sets, I will index by upper arrow for the non-decreasing function, with 0 for the function which are null at the origin, and with the 0 plus if the right limit at the origin is null. Then, as I need to transform piecewise continuous in left or right into left or right continuous function, I will introduce function modifiers as the right and the left extension, who map the piecewise continuous function to the left or the right one, and that's graphically said that I stick the discontinuities on the left or right segment. It depends on the left or right extension. I can extend this notion of extension to the server, and I will say that a right server extension of the server is the right extension of the flow, such that it exists this flow in the original server, reciprocally with the left extension. So that's the notations. Well, to come back on the definition of the cumulative curves, as you know, there are left or right continuous, depend on the model. There are non-decreasing functions. There are null at the origin, and we assume now that the limit at the origin, the right limit at the origin, is null. This last point is a technical restriction of the current definition. It's not in the current one, but we need to add this one, this restriction. We also work on the convolution products, and so we have the first known results, which is the left continuous function or stable under the convolution. But we can go further with the left extension and we see that the left extension of a convolution product between F and G is equal to the convolution product between the left extension of F and the left extension of G. The same way we work on the right continuous function, and we have a bit stronger property, which is we only need to have one of the two functions in the left continuous non-decreasing function set of function. They are such that they are null at 0 to have the product convolution in the same set. And with the right extension of the convolution product, we only need to have one of the two function with the extension if the function is the limit of the function, the right limit of the function at 0 is equal to G0. Okay, so that's the end for the mathematical backgrounds, and with all those results, we can make equivalences between the left and the right word. Concerning the arrival curve, we have that they are preserved, passing from a word to another. That is to say, if I take an arrival curve of a cumulative curve A, this arrival curve is also an arrival curve for the right and the left extension of A. Then, concerning the services, we generate the definition of the services to take into account the fact that the cumulative curves can be left or right continuous. And we want to see if the relation between the departure and the arrival curve are preserved. So we will have three services preserved. The min plus minimal services, the maximal services, and the shaper. But we will see that we lost the strict minimal services, passing from a word to another. So that is to say, just to see you, if I take a server in a left word, so we have D greater than A, the product convolution between A and beta, then we have the same relation in the right word, so the right extension of the dot function respect the same relation. And we can come back in the left word, adding the left extension on beta. So it's a bit modified, but not too much. Then we have equivalence between the maximal services. So that is to say the relation is preserved passing from a word to another. We have exactly the same with the extension. Here it's a not a R. And the same way we have equivalence between the shapers. However, as I said, we have non-preservation of the strict minimal services. That is due to the fact that the backlog periods are not preserved passing from a word to another. So let's take an illustration. So if we consider this simple service network with server S mapping A to D, as illustrated at the top of the figure, and just behind we have the right extension of this server. We assume that the cumulative curve as illustrated on the graphs, with on the left the left extension, the left one, and on the right one, the right continuous one. We can see that, for instance, the segment 2 semi-closed 2.5 is a backlog period for the right cumulative curves and not for the left one. So we have non-preservation of the backlog period passing from the right world to the left one, for instance, here. But we can note that all the segment, the small segment 2, 3, 3, 4, 4, 5 are backlog period for the two worlds. So that means, so the non-equivalence of the backlog period seems to be due to the discontinuity of the cumulative curves. Then, according to this example, we can take, for instance, a service curve beta equal to 2 times t minus 1, and we see that this service curve is a strict minimal service curve for S, but not for S, the right extension of S. So we have no preservation passing from the left word to the right one. Then the same way, we can construct another sample and see that, and we see that we have non-preservation for the strict minimal service passing from the right word to the left. So we lost the strict minimal services passing from a word to another. However, as we see in the sample, the non-preservation seems to be due to the discontinuity of the cumulative curves. So I will just present you some preliminary work which are based on the improvement adaptation of the definition of the backlog period in order to have a preserved strict minimal service. We think about two new definitions of the backlog period called stable backlog period, which the first one is very similar to the current one, but it didn't take into account the isolated points, such that there is equality between A and D. And the second one is a bit more general because we can consider that it exists a finite number of points in the interval such that there are equality. It's two different definitions and we don't know yet which is the best, but we have equivalence between the left and right words with those definitions. And then we can construct a new strict minimal service with the new definition of the backlog period and that we call strict non-nap services. And with this definition, we have equivalence between the left and right world. So to illustrate the usage of the results, we can take this simple example. This is a network composed of a server S, which is a static priority server with a strict minimal service beta, and P a packetizer. We assume that A prime is higher priority than A, and they are left continuous, and L prime packetizer it. So we want to analyze the flow AC. Under this hypothesis, we can use some properties such that beta minus A, the arrival curve of A prime is a strict minimal service curve for A, and also that a strict minimal service implies a min plus minimal service. Then, according to the theorem, we can pass from the left word to the right one, and we have the same service curve. In this world, we can have this minimal service curve for the sequence SP that maps AR to CR. And then finally, we can come back to the left word if we want to come back in the left word with the same theorem, adding the left extension on the server, on the service curve. Sorry. Then we have a service curve for the sequence SP that map A to C. This is an example, and there is some other possible usage. And we can, for instance, add the link with CPA to improve or have more results. So finally, to conclude, if we naively conclude, we can say that we can ignore the question of the right or left continuity on the cumulative curves. But in reality, we have shown some relation between the left and right worlds, respecting some conditions, and we can then use the results of the world where we are. And the aim of this work for us is to link the network calculus theory with CPA in order to analyze more components, applications, and system. And to continue on this work, we can work on the suggested solution for the strict minimal service and see if the network calculus theory continue to work with the new definitions of the backlog periods. Thank you for your attention. And if you have any question, I can try to answer.
Thank you. Well in time, so question, please remember to read.
Yes, okay.
The choice why the min plus calculus uses the left continuous version is one of convenience. It's not about getting different expectation of different results. There's a book, Computer Networks and Analytical Approach from 2000 or so, 2000 something too, by Manjunath and Kumar. They developed the entire network calculus in a right continuous framework. And if you're following this, and I taught it once, then just very inconvenient because you always have to have the inf over 0 plus, you know, it's just always, and isn't that the only difference? I mean, I understand the issue with the busy period, but the busy period, I mean, if there's no point, and as you say, if there's only an isolated point where the backlog is 0, then if you extend the busy period, you get the same results. I mean, it doesn't change anything.
Okay, so
I mean, it's why?
Thanks for rephrasing.
okay, so
It was a comment as well. I mean, it was not only a question that you repeat. I made a comment here on kind of there is
okay.
the right continuous evolution of the min plus network calculus, and nobody ever said that this would be different or there would be an expectation that anything would be different.
Okay.
So why would you expect it to be different?
So you're asking for the aim of the
That's right.
the work. So in fact, we want to the major motivation for this work is we want to use the results, the link with TPA, and all these results are developed with the fact that the cumulative curves are right continuous, and to be order to in order to use also the network calculus results, I need to find relation between those two assumptions because I don't want to reprove all the results show developed in with the left assumption. So that's why I need to, if I found the service curve, I want to add the same relation with the left, with the right cumulative curve, and then can use also the both results. I don't know if I'm clear, but
I mean, kind of network calculus is the byproduct that gained from this work, from proving it in a general sense that the CPA everything can be moved over.
Yeah,
and,
yeah. Maybe I'm.
we can discuss that after.
We
Sorry.
have more questions, comments. We have time for a short one. If not, doesn't seem so. And thank you for your presentation.
Thank you.